Our knowings of the solar system would be amateur if it were not for the infamous spacecraft Voyager. The two identical probes, Voyager 1 and Voyager 2, are now the farthest human-made objects to leave our planet's view. The two of them were launched way back in 1977, and they completely changed our textbooks on the cosmic heavens. They visited Jupiter, Saturn, Uranus, Neptune, and their moons, and if you're wondering how they work, we'll get there really soon. But first, Voyager, flying through interstellar space. First up on Voyager, we have the housing bus, a 10-sided aluminum box that stores electric parts. Thus, circuitry and radios are stored inside its shielding. Plus, it shows the golden record so aliens can get to know us. The golden record has music from Bach to blues to rock and roll and features images of human culture, heart, and soul. The OCT is used to calibrate the cameras as a whole. A rectangle of known brightness can really play an important role. You're thinking, where's the power come from on the Voyager freighters? Well, the radioisotope thermoelectric generators. There's 3 units acting as electricity translators from the heat emitted from plutonium-238. Her high-gain antenna measures 12 feet wide. It transmits data back to Earth with prowess and with pride. On 2 different frequencies tells us about its health and sends the science data worth a multitude of wealth. Yeah! Voyager, flying through interstellar space. You may have noticed a gold rod stretching from the bus. That's the magnetometer, held by a 43-foot truss. It finds magnetic fields on planets, moons, even the sun. The amount of data it has found, it truly is a ton. The PRA and PWS stretch out in a V shape. They detect the tiniest radiation from the landscape. They found radio wave emissions from Jupiter and from Saturn, and they function to this day, sending interstellar patterns. The Imaging Science Subsystem has the most important mission: to take photos with its cameras of planetary conditions. It mapped the rings of Saturn and captured the Great Red Spot, and from 6 billion clicks, Earth's just a pale blue dot. The photopolarimeter is the onboard telescope. It determines compositions of a planet's envelope. The iris looks at planets with a sensitive thermometer, and UV light is detected by the ultraviolet spectrometer. So you really wanna be an expert spacecraft connoisseur? Well, there are 3 particle detectors on each of the Voyagers. The CRS has the highest sensitivity. It measures high energy ions to a very precise degree. The LECP also detects particles out in space. It focuses on low energy galactic cosmic rays. Last, the plasma subsystem. It found the heliopause. We're interstellar space farts where we've left the sun's claws, and that's Voyager, flying through interstellar space. Now that we know all about Voyager's many tools, let's take a look at what they found. It really is so cool. On Jupiter, they proved the Great Red Spot a Great Red Storm and found a giant magnetic field. Way to outperform. They visited Io, one of Jupiter's great moons. They found active volcanism shooting up like a balloon. Europa was revealed to have really decreased relief. They even found rings around Jupiter, if you can believe. The Voyagers reached Saturn by 1981, and they found Saturn's rings to be a whole lot of fun. Turns out they're made of tiny particles of ice, rock, and dust. Perhaps they once composed a satellite's crust? Titan, Saturn's largest moon, was really quite a sight, but the atmospheric surface pressure really is a fright. It's made of nitrogen and methane and will break you like a knife, but it's full of organic matter. Could it maybe host life? Voyager, flying through interstellar space. We were so pleased after seeing Jupiter, Saturn, and their moons that Voyager 2's mission was extended to Uranus and Neptune. Uranus' magnetosphere twists to a corkscrew shape, and the tallest cliffs in the solar system are on Miranda's landscape. At Neptune, Voyager found a great dark spot, and the fastest winds in the solar system, over 1,000 knots. It found giant nitrogen geysers on its moon Triton, which at 38 Kelvin will leave anyone frightened. To this day, the Voyagers continue on their missions to determine what it's really like in hostile conditions, traveling at 60,000 kilometers an hour, a truly breakneck pace. In 2012, the first entered interstellar space. In 2016, the science equipment had to be shut down, but they still detect some radiation and send it to the ground. They will still have some power for a few more years, then they'll wander the Milky Way, never more to appear. Let's go! Voyager, flying through interstellar space. But despite these great advancements, was it really worth the cost? $865 million down the drain and lost. It's getting more expensive every year as they get farther away, and the data they've provided will have no use for us anyway. But that's not true. Voyager's findings have revolutionized astronomy. The data found from the outer planets have fueled curiosity. The cost of it is nothing per capita per year. It's one of the most successful missions, working for 45 years. To sum up, Voyager has been a hugely great success. It's helped us understand the truth of our cosmic address. It helped complete the drawing of our solar system's map, and the cost of it will never be seen as a useless scrap. The complex instruments all play very specific roles, and we've even left a message for aliens on board. And now you know all about the Voyager spacecraft. Who knows just how long Voyager's legacy will last. Voyager, flying through interstellar space. Voyager.